everyone, I'm Princess Ayan Kumpok and I'm from College of Business Administration Education with the course of BSBA major in Financial Management first year college. I'm here today to report about inductive reasoning. My objective is not just to try and persuade you all to take a stand on this topic, but I would like to try and report and present to you the real meaning examples about inductive reasoning. So we have learning outcomes. At the end of this lesson, you are expected to 1. Use different types of reasoning to justify statements and arguments made about mathematics and mathematical concepts. Number 2. Write clear and logical proofs. Number 3. Define and differentiate inductive reasoning and deductive reasoning. Number 4. Give examples of inductive reasoning. Number 5. Demonstrate ability to validate a proof. There is a question here. What exactly is inductive reasoning? Inductive reasoning is the logical process in which multiple premises, all believed to be true or found true most of time, are combined to obtain a specific conclusion. And also, it is the opposite of deductive reasoning. It makes broad generalizations from specific observations. Basically, there is data, then conclusions are drawn from the data. And also, a conclusion is reached by inductive reasoning may or may not be valid. An example of inductive reasoning is when you notice that all mice you see around you are brown, and you make the conclusion that all mice in the world are brown. Can you say for certain that this conclusion is correct? The answer is no, because it is based on just a few observations. All forms of inductive reasoning, though, are based on finding a conclusion that is most likely to fit the premises and is used when making predictions, creating generalizations, and analyzing cause and effect. We have here the two types of reasoning or arguments: deductive arguments and inductive arguments. So, deductive arguments are meant to prove a conclusion, while inductive arguments are meant to predict a conclusion. An inductive argument is either considered as 1. Weak induction and also a strong induction. We have here weak induction. Weak induction is when your particular view on something does not allow you to see that the conclusion is likely given to evidence, and also it tends to be false or based on a very limited examples of facts. While strong induction is when you decide to believe the conclusion is true based on the evidence, and also the conclusion of strong inductive is usually likely to be true. We have here example of weak induction. I always hang pictures on nails. Therefore, all pictures hang from nails. This is a weak induction because not every picture is hung from a nail and not everybody hangs pictures from nails, so it can be proven false. We have also here the example of a strong induction. All the tigers observed in a particular region have black stripes. Therefore, all the tigers native to this region have black stripes. This is a strong induction because it has not been proven false yet, based on observations taken. We have here 10 examples of inductive reasoning. Number 1. Use inductive reasoning to predict the most probable next number in the given list: 1, 8, 27, 64, and 125. We have the series of numbers here, and then we're going to find the next number after the 125. So the series of numbers are 1, 8, 27, 64, and 125. And the next is an unknown. So if you notice, this series of numbers has no pattern. So what I'm going to do now is to find the pattern. So this is what I did. Find their differences from first number to the last number. So if you notice, 8 minus 1 is 7, 27 minus 8 is 19. 64 minus 27 is 37. 125 minus 64 is 61. In this case, we can find the pattern. So what I'm going to do is I try to find its difference again. So 19 minus 7 is 12. And 37 minus 19 is 18. 61 minus 37 is 24. If you observe these numbers, 12, 18, and 24, if you add 6 in 12, the total is 18. And 18 plus 6 is 24. So they have a common point. Example, this one. 18 minus 12 is 6. And 24 minus 18 is 6. So it means the next number of 24 is we're going to add 6. So 24 plus 6 is equals to 30. And then, meaning you will add 30 and 61. For this number, 37 plus 24 is 61. And then 61 plus 30 is 91. Which means the next number to 61 is the 91. It means the number next to 125 is, you have to add 125 and 91. The total is 216. So 216 is the next number of 125. So this is our prediction. Number 2. Use inductive reasoning to predict the most probable next number in the given list. 5, 14, 10, 19, 15, and 25. So example number 2, we have the series of numbers here. 5, 14, 10, 19, 15, 25, and the next number is unknown. So you can see their differences are here is from 5 to 14 is plus 9. And 14 and 10 is minus 4. So 10 and 19 is plus 9. And 19 and 15 is minus 4. And 15 and 25 is plus 10. There's a pattern, but in the last number is plus 10 instead of plus 9. So what we're going to do now is the alternate. The 5, 14, 10, 19, 15, and 25. The next number is unknown. So 5, next is 10, next is 15, and the next is 20. Supposedly, the next number is 20. Three, determine the next number. 3, 6, 9, 12, and 2 unknown numbers. Example number 3, we have the series of numbers here. 3, 6, 9, 12, and 2 is an unknown. 2 numbers is unknown. So the pattern here, as we can see, from 3 and 6, it's plus 3. 6 and 9 is plus 3. 9 and 12 is plus 3. It means you have to add 3 in 12. Total is 15. And also here, add 3 in 15. The total is 18. 15 and 18 is the unknown numbers. The next number will be 15 and 18 because all numbers can be added by 3. Example number 4, study the pattern and determine the next figure. So we have here in the first line a 1 heart, and we added the down part, that's 2 hearts, and also the 3 figure, we add 3 hearts, and the 4th figure, we add 4 hearts, based on the number of heart increasing 1 heart per level. Example number 5, Jill and Ali are friends. Jill likes to dance, cook, and write. Bob likes to dance and cook. Therefore, It can be assumed that Bob also likes to write. Example number 6. Which figure comes next in the sequence? We have here the choices A, B, C, D, and E. Example number 6. So we have this in the pattern. There we have to decide which one actually fits there. So we need to decide which one fits there in that sequence. So let's use our same methodology for answering this inductive reasoning test. So you'll notice that has got 5 sides. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And that so we are looking for a 5-sided shape that goes there. So if you look at the bottom, only C and E have 5-sided. So straight away, we can eliminate A, B, and D. From our answers, so all of a sudden, we're down to our 2 options, the C and E. If we are to look at another particular element of the sequence, let's choose the black square. We can see it's moving around clockwise. Is one there is black, but there's white, and there's black, white, and then black. So it's rotating clockwise 90 degrees each time, so that means that one there would be need to be right in this particular corner, and the only answer from C and E is letter E. That's the only one variable that fits that particular element. So don't forget, just pick one particular aspect of each shape or figures and have a look for a pattern within. So the answer here is letter E because it have 5-sided 1, 2, 3, 4, 5. Number 7, use inductive reasoning to predict the most probable next number in the given list. 3, 6, 9, 12, 15, and 18. Example number 7, we have the series of numbers here, 3, 6, 9, 12, 15, and 18. And the next number is an unknown. So what we're going to do here is just simply add 3. So 3 plus 3 is 6. 6 plus 3 is 9. And 9 plus 3 is 12. And 12 plus 3 is 15. And 15 plus 3 is 18. And 18 plus 3 is 21. So 21 is the next number of 18. 21 is the answer. Example number 8, use inductive reasoning to predict the most probable next letter in the given list. C, E, G, I, and K. So example number 8, we have a series of letters here, C, E, G, I, and K. So their differences is only one letter, C, D, C, D, E. Next to E is C, D, E, F, J, H, I, J, K, L, and next to L is letter M. Therefore, letter M is the next letter to letter K. Number 9, use inductive reasoning to predict the most probable next letter in the given list. I, K, M, O, Q. So we have here example number 9. We have here the series of letters I, K, M, O, Q. So again, their differences is only one letter, I. Next to I is J, I, J, K, L, M, N, O, P, Q, and next to Q is letter R, and next to letter R is letter S. Therefore, as letter S is the next letter to letter Q. And last one, number 10, use inductive reasoning to predict the most probable next letter in the given list. B, D, F, H, J. Example number 10, we have here the series of letters B, D, F, H, J. And again, their differences is only one letter. So B, C, D, E, F, G, H, I, J, K, and next to letter K is letter L. So letter L is the unknown letter next to J. Wrap up. Inductive reasoning. Inductive reasoning is the logical process in which multiple premises, all believed to be true, are found true most of the time, are combined to obtain as a specific conclusion. And also, it is opposite of deductive reasoning. It makes broad generalizations from the specific observations. Basically, there is data, then conclusions are drawn from the data. Thank you for listening. I hope you learned a lot about inductive reasoning.